last thing we're going to be looking at this week has to do with solving rational equations. Now, we did rational expressions. We were adding and subtracting, multiplying, dividing, right? Remember, rational simply means it's a fraction, right? And equations now are going to have an equal signs. Okay, so actually these are way easier than the other things we've been working with. Okay, so quite often in order to solve problems, we're going to end up developing. So you're going to have to figure out, develop, and solving equations. Because that's kind of the whole point of all this. We want to try and figure out some kind of equation in order to solve a problem, and then you're going to try and solve the equation. And to make your life easy, usually the thing you're going to be looking for, we call that thing x, because we like x. X marks the spot, right? So careful. This is an expression, right? 4/3 plus 2/5. Okay, that is some expression. I can add the two of them together with a common denominator, or I could have it multiplying or something. But the answer is going to be a fraction, right? Answer is equal to, I don't know, it's going to be times 5. So 20/15 and 20 is 26/15. Whatever it is, it's a fraction. An equation has an equal sign. So think of this. 4/3 plus x is equal to 2/5. Okay, that's a little different. But here's the thing. In order to solve, I don't have to be using these fractions. Here's what I could do. I could multiply, oh yeah, by 15 on both sides, right? Multiply by 15. Why? What does that do? Because 15, this makes it sixths, right? 30 over 5 is 6. Okay, and this gives me 15x. And 15 times 4 is 60. 60 divided by 3 is 20. No more fractions. So you can get rid of the fractions. Get rid of fractions. Now, with the other ones before, these ones, the answer is a fraction no matter what, right? Because I got fraction, I got to get common denominators. But in this case, I can avoid the fractions. That's what I want to do. If it's an equation, that's the difference. You can multiply both sides by 15 and the fractions will disappear. So that's really it. The biggest difference in dealing with rational equations is now you can multiply both sides. Both, oh, it's a terrible both. Both sides by, now what did I multiply by? I multiplied by 15. Why 15? Because 5 and 3. Oh yeah, 15 is a multiple of both 5 and 3. Both sides by the LCD, the lowest common denominator. And what happens? It will cancel out those denominators. Okay, now you're still going to have to factor everything in order to figure out what the LCD is. And you're also going to have to give non-permissible, right? Give non-permissible. Permissible, there we go, values, right? So what can x not equal? Okay, so, but here we go. This is a big equation. I got a fraction plus another fraction. I got a common denominator and combine those. No. Step one, factor everything, right? By this stage now, as soon as I see a difference of squares like this, I know I'm going to factor it. So let's try it. 2 over x plus 2, x minus 2, right? X squared minus 2 squared. 10 over, I can factor out 6. 6 bracket x plus 2. Hey, there's that x plus 2. It's the same factor. And 1 over x minus 2. Oh, there's the x minus 2. It's the same factor, right? So once I actually factor this thing, I can figure out what the LCD is going to be. So lowest common denominator. Do they have anything in common? Well, x minus, or x plus 2, x plus 2. It's got to have an x plus 2 in it. It's got to have an x minus 2 in it. Right, there it is, there it is. Oh, and it's also got to have a 6. Now, I could have simplified this thing down. No, let's not bother. We'll just make it 6. So times 6. So that's my LCD. Now, here's what we did before. We multiplied on top and bottom by, oh yeah, what's missing? I'm missing the x plus 2, x plus 2. We're not doing that this time. 6, 6. We multiplied by what it was missing in order to create that, right? I'm not doing that this time. I'm not going to multiply top and bottom. I'm only multiplying on the top. Not, well, because here's the idea. I want to get rid of the bottom. So But you can't do that. You're changing it. Remember before we had to multiply by 1? Not so with equations. With equations, you don't have to multiply by 1. So here's what I'm going to do. I'm going to multiply both sides by the LCD. So this, I'm going to go times, well, let's do this in a different color here. We'll show it. This, I'm going to multiply this side by 6 and x plus 2 and x minus 2. And I'm going to multiply this one by 6, x plus 2, x minus 2. Why? Let me show you why. Because watch what happens. When I multiply here, the x plus 2 and the x minus 2, they cancel. I'm left with 6 times 2. See that? X plus 2, x minus 2, x plus 2, x, those cancel. I'm just left with 6 and 2. Let's get rid of those. Go, go. But I'm left with 6 times 2. Great, that was easy. See, that whole fraction disappeared. Now when I do it here, hang on, let's make this thing bigger. Doop. When I multiply here, the x plus 2 cancels, the 6 cancels. However, the x minus 2 is still multiplied by 10, right? So x minus 2 times 10, so I'm going to get 10 x minus 2. Okay, what happens over here? The x minus 2, boop, this and this cancel, but it's still 1 times 6 times x plus 2, okay? So it's going to be 6x plus 2. Done. That's an easier, way easier equation to solve. Well, let's actually solve it now. 12 plus 10x minus 20 is equal to 6x plus 12. That's not bad. Minus off 12 from both sides. Guess what? Those two can't just cancel it. So 10x minus 20 is equal to 6x. Minus off 6x from both sides. I get 4x is equal to, I'll bring this over, it becomes positive 20. There we go. X is equal to 5. Ta-da! There's my answer. Now, hang on. Is that right? Oh, remember, we always have to go back and check these things with other equations we did, but hang on. The only things I really need to check here are the non-permissibles. I didn't say what x could not equal, right? What is x not equal to? Okay, well, let's go up. Positive 2. This factors into x plus 2. So minus 2, positive 2 minus. That's it. Those are the only two restrictions. X is not equal to plus or minus 2. So that's what x cannot equal. I just wrecked that up. X cannot equal plus or minus 2. Duh, it's equal to 5. So 5 is okay. 5 is going to be the answer. It's going to work. Now, we could go back and plug it in, right? 5 squared minus 4 and blah, blah, blah. You plug it back in here. It's going to be ugly. It would work no matter what. Really, the only thing I need to check are my restrictions. So if it's not one of your restrictions, then this should be okay to go. So these equations get pretty big and pretty ugly, but here's the idea. If you can factor things, if you can recognize what the factors are, and then I'm multiplying. Now remember, I only multiplied on the top. I didn't multiply top and bottom because I want the bottoms to cancel out, and that's what happened here, right? Once the bottoms cancel out, there's no more fractions, then my life is way easier. Okay, let's try this one. 4k minus 1, k plus 2, k minus 1, k minus 2. Yikes. This thing's a trinomial. It'll probably factor, right? And, oh, there's a k plus 2, k minus 2. Cool, let's do this. So 4k minus 1, k plus 2, k plus 1, k minus 2. What does this thing factor out to? Two numbers that multiply to 24. So it's either 1 and 24, 2 and 12, 3 and 8, 4 and 6. Multiplies to 24, adds up to negative 4. Yeah, and this adds up to negative 2, positive 2. This thing doesn't factor. Hang on. This is positive and this is negative, which means they're both negative, right? If they add up to a negative and they multiply to a positive, they're both negative. This thing doesn't factor. Okay, well, don't break it down. Leave it alone. So just leave it like this. K squared minus 4k plus 24. It doesn't factor. Leave it alone. However, the bottom does. Oh yeah, I recognize the bottom. K plus 2, k minus 2. K plus 2, k minus 2, k plus 2. There it is. There's my LCD. I can see right off the bat that my LCD is going to be k plus 2 and k minus 2. So remember, I'm going to multiply it on the top only, not top and bottom, because I want the bottoms to cancel, right? K plus 2, k minus 2. Okay. So when I multiply it here, the k plus 2 cancels, but I'm left with k minus 2. Oh yeah, see that? The k plus 2, those two cancel. So I'm left with k minus 2 times 4k minus 1. Okay, so let's do that. Minus. Now, when I do it here, k minus 2, but the k plus 2 times k plus 1. Okay, so this becomes k plus 2, k plus 1. Careful, I'm subtracting this, right? So I'm going to have to expand this thing all out first, then do that. Okay, what about here? This and this cancel with this and this. So I'm just left with the top. That's actually kind of nice. So that's why this thing didn't really factor. Okay, let's try it. 4k plus 24. Okay, so I've got a bigger equation, but there's no fractions. Let's just expand all this stuff all out. What do we get? So I get 4k squared minus k minus 8k minus plus 2. Subtract off, now hang on, let's expand this thing all out. This is going to be k squared minus 1 minus 2. So plus 3k plus 2. K squared minus 4k plus 24. Okay. 4k minus k, I get 3k squared minus 9k minus 3. So careful, minus 9, subtract 3. It's going to be minus 12k's. And then positive 2 minus positive 2. Gone. So it's just that equal to k squared minus 4k plus 24. I'm getting closer and closer. Let's move everything over to the left-hand side. 3k squared minus 1k squared is 2k squared. Plus 4k to both sides. Plus 4k plus 4k. Minus 8k minus 24 minus 24 is equal to 0. I'm getting closer. Oh, they're all divisible by 2, right? I can factor out a 2. No. You don't need to do that. Remember, this is an equation. I can divide both sides by 2 because 0 divided by 2 is still 0. Oh yeah, so the 2 in this case kind of disappears. Yes, you could factor it out, but it's easier to just divide by 2. Okay, what do we got? K squared minus 4k minus 12 is equal to 0. I could go to the quadratic formula, or I could recognize I know how to factor this thing. Two numbers multiplied to 12, sorry, minus 12, add up to minus 4. Well, this is an easy one, so it's a k and a k. I know that. Minus 6 and plus 2. Hang on, does that work? They add up to minus 4. They multiply. Yes, it is. So here we go. K is equal to positive 6, or k is equal to negative 2. Ta-da! There's my two answers. And as always, with any kind of quadratic, I get two answers, and I know that they're perfectly okay. No. Go back to the very, very beginning. Remember my restrictions. What can k not equal? Cannot equal positive 2 or negative 2. Positive 2, negative 2. Are those the only denominators? Yes, they are. Oh, no. This one is a restriction. It has the restriction that k cannot equal plus or minus 2. So that one's definitely wrong. But that one should be good to go. So once again, much like when we were doing the things with the radicals and stuff like that, if you end up getting a square or a quadratic equation, that's why we did those earlier in chapter 4. If you get a quadratic, you're going to get two answers, and you should always be suspicious. Think, I wonder if one of them doesn't work. Now, before it didn't work because it would give you a square root instead of a negative. But now, the reason it doesn't work is it's a restriction because you cannot go divide by 0, right? Something divide by 0 gives you a massive problem. Okay, last one. A championship dog race runs nonstop from the Paw to Flin Flon and back. That's right, the Paw. It's not the pass. The Paw and Flin Flon. These are two actual places in Manitoba, way up north. This one's named after Flintabody Flanaton, I think is the name. Believe it or not, that's real. Flintabody Flanaton. That's somebody's actual name. Look it up, it's true. Okay, so the total distance is 140 kilometers. That's there and back. Or no, hang on. Yeah, from the paw to Flin Flon and back. So there and then back. Okay. The winner ended up decreasing her speed by 6 kilometers an hour on the return leg, so she's going slower on the way back, and the total time was 8.5 hours. That's pretty fast, right? 8.5, well, 4 hours to get there and 4 hours to get back approximately. What was the winner's average speed for the first leg? Oh, man. And like I have an entire page to do this question. Okay, so this is a big question. This is a distance, speed, time one. Distance, speed, time. This comes up an awful lot in physics, and that's exactly where this comes from. We're going to do this with rationals because there is a relationship between distance, speed, and time. I never get this right. Some people say it's like the dirt triangle. Distance is speed or rate and time, and I'm not sure. Is that the way it works? I remember Budak mentioned this once. And you cover this one up. Distance is equal to speed times time, or I never remember that thing. Okay, here's the easiest way to remember it. Speed. You know what speed is. If I'm driving along in a car, my speed is going to be in kilometers per hour. Well, kilometers is a distance. Hours is a time. There we go. So my kilometers is a distance. My hours is a time. There we go. Speed is equal to distance divided by time. I always remember my speed because it's in kilometers per hour. I'm doing 100 kilometers an hour or 90 kilometers an hour, whatever. So distance over time. Now you could also take this t and multiply it up there, and you get t times s is equal to d. Or you could, so I could solve for d, I could solve for t. There's lots of different ways of writing this. But hang on. The championship dog race runs from here and back. The distance, there's my distance. The winner ended up decreasing her speed, so we're talking about speed, and the time was here. Now it says, what was the winner's average speed for the first leg? That's what I'm going to call, that's what I'm looking for. What is the average speed? That's what I'm going to call X or S or T or whatever you want to call it. So we're talking about the first leg and the second leg. So distance, speed, time. There's two different things we need to discuss here. There's the first part and the second part. So we're talking about going there and then coming back because it says she decreased her speed. So we're talking about the first leg, so there, and then the second leg, there and back. Or you can call this the first part and the second part. What was the distance? Was it 140? No, 140 is the total distance. So does that mean it has to be 70 and 70? Well, unless you moved one of the towns, but it has to be. Yeah, if it's there and back, it's exactly 70 and 70. Okay, that's the easy part. Do we know the speed? It says the winner ended up decreasing her speed by 6 kilometers an hour on the return trip. So coming back is slower. I don't know this. The total time is 8.5. What is the winner's average speed? What is the winner's average speed for the first leg? That's what I'm looking for. So that's what I want to call X or Y or Z or whatever. I'm not going to use S. S would be a good one but my S's look like 5s. So I'm going to call it X. Okay. What about coming back? Is this X plus 6 or X minus 6? The winner ended up decreasing her speed on the return trip. So coming back, she's going slower. It's X minus 6. Okay, there we go. What's the time? I don't know the time. Is it 8.5? No. No, it's not because it says the total time. Okay, so does that mean that this is going to be 4.25, half and half? 4.25 and 4.25. That would be easy to remember, but it's not. You're doing two different speeds. It can't be the same time. Coming back, you're going slower, so this time should be bigger. So this is probably more like 5 and 3, but this one's got to be bigger. I don't know what this time is. Ah, man. If only I had a formula to tell me what time is. Yes, time is equal to distance divided by speed. There it is. See? Time is equal to distance divided by speed. 70 divided by x. And so this one is going to be 70 divided by x minus 6. 70 divided by x minus 6. There's the time. But I thought the total time was 8.5. If I go this plus this, it should equal 8.5. That's an equation. That's where this comes. That's where we're going to get to. Okay, so I had to get to here. So this little distance speed time chart is a good thing to fill out. One of them is going to be straightforward, one of them's got to be variables, and one of them is going to be fractions. How do I know? This is called rational equations. That's how I know, because this entire lesson's all about fractions and equations. Okay, so here we go. This plus this should add up to 8.5. That's an equation. 70 over x plus 70 over x minus 6 is equal to 8.5. There's my equation. I can see my lowest common denominator is this and this. I'm going to multiply. I'm going to solve this equation. Okay, so getting to the equation is the hard part. Solving is actually the easy part. Now, before we solve this, let me show you an easy way to remember this. Easy? Sure. Let's say I got these backwards. Let's say I had them the other way around. X minus 6 over 70. And then the other one is going to be x over 70, right? Yeah, it's easy to get these backwards. Look at that equation. It's not really rational because, well, this is a fraction, but it's not a fraction with an x. It's a number. And they have the same denominator. This is an easy equation to do. This is way too easy. I've obviously done something wrong. It shouldn't be this easy. You could do this in grade 9, add two fractions with the same denominators, right? Grade 8 and grade 9 kids could solve this because they have the common denominator. So I know that I've made a mistake here. So let's go back. Let's get this back to what it should be. There it is. This is a way harder one because I've got two different denominators. And, by the way, the denominators have x's in them. Okay, so let's get rid of these. Get rid of them? Yes, by all means. Because I'm going to multiply by my LCD, which is x and also x minus 6. X and x minus 6. So I need to multiply it there, and I'm going to multiply it there. This is 8.5, which is a decimal. If I was smart, I'd multiply by 2 as well. What? Because that'll double this thing, which gets rid of the decimal, right? So let's actually multiply by 2 as well. Why? You don't have to, but it just, when I multiply 2, this becomes 17, which is a nicer number. It's way easier to deal with than a decimal. Okay, let's do this. Here we go. When I multiply this by here, the x cancels. So I'm left with 2 times x minus 6 times 70. So I'm left with 140 times x minus 6. What about here? X minus 6, x minus 6, cancel. 2 times x times 70. Okay. So I'm left with 2 times x times 70. I'm left with 2 times 70 x. That's not bad. When I multiply here, there is no fraction. So it's really going to be 2 times 8.5, which is 17, times x minus 6. Oh, man. This is going to be ugly. No, it's not. There's no more fractions. The fractions all disappeared. So it's actually now let's just multiply this stuff out. Okay, here we go. 140x minus 602 minus 840 plus 140x is equal to 17x times x, 17x squared, yikes. 17 times minus 6, 60 and 42 is 102. So that's minus 102. Or is that 112? No, it's 102x. You know what? I better double check that. 17 times 6. Yep, 102. Good. There's no point in making a mistake halfway through. It's a quadratic equation. I need to make this thing equal to 0. I'm not going to move this over because it becomes minus 17. So let's keep it on the right-hand side. However, 140 is 280. So I got 100. I'm going to subtract off 280x. Yikes. So I've got 17x squared minus 280. So this is going to be minus 382x. Yikes. Minus 840. So plus 840 is equal to 0. Yikes. That is a big number. Hang on. Can I divide out 17? Is 840 divisible by 17? No. This one's definite. So this is not going to be very nice numbers at all. So now what? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 Okay. I have to use the quadratic formula. I have no choice because I'm not going to factor this thing. 17 times 840, well, whatever. Okay, so negative b, which is 382, plus or minus the square root, whoa, b squared. So what's 382 squared? Whoa, 145,924. Yeah, like I knew that. 145,924 minus 4 times 17 times 840. Make sure that square root goes over the whole thing. The whole thing is being divided by 2 times a. So 2 times 17, which is 34. Okay, so what do we get? So 145,924 minus 4 times 17 times 840, which is 88,804. So then I'm going to do the square root of that. Whoa. Here we go. So this is 382 plus or minus. The square root of that number was 298. Whoa. Over 34. This is going to give me two answers. Okay, so hang on, let's just do this. So 382 plus 298 is going to give me 680. Let's go divide by 34. That's going to give me 20. What's the other one? So 382 minus 298. And then I'm going to go divide by 34. Boop. Is 2.47. So in other words, around 2.5. Okay, so I got my two answers. Remember, what are my restrictions? X cannot equal 0 and positive 6. X is not equal to 0, and it's not equal to positive 6. Well, duh, that's your speed. Your speed's not going to be 0, and it's not going to be 6. Is that the answer, or is that the answer? Hang on. Let's read it. It says S is the speed going there. Coming back, she went 6 kilometers slower. This can't be it, because then you'd have a negative speed. No, this gives a negative speed. What? Think about it. If you're doing 2.5 kilometers an hour there, when you subtract off 6, you're doing like negative 3.5. No, it's got to be bigger than 6. This one's going to work. So 20 kilometers an hour is her speed going there, and then coming back, it's going to be 14. Ah, that makes sense. So 20 kilometers an hour going there. So if this is 20. So what's 70 divided by 20? So 7 divided by 2, which is 3.5. And then 20 minus 6, which is 14. What's 70 divided by 14? 70 divided by 14 is 5. Oh, that makes sense. 3.5 hours, 5 hours. There's the total time of 8.5. So what's the answer? Let's go back. If the total time was this, what was the winner's average speed for the first leg? Her average speed was her first speed was 20 kilometers per hour on average. That's for the first part. Ta-da. Okay, so don't worry about day 2 right now. That'll be next week's stuff. Today, we're just going to look at the first part, so 2 through 8. And I do believe I'm going to have those ones online. So these ones are actually way easier than before because we can get rid of the fractions. And if it does turn out to be an ugly quadratic like this, by all means, you have a quadratic formula. Use it. You don't want to be doing these things by hand. Alrighty. That would be solving rational equations part 1. Good luck.